All right, everyone. Thank you for coming. I mean, this is amazing. I have never been in a room like this. I have given a talk in a church, but I have never given a talk in a movie theater before. So this is a achievement. Well done for me. My name is Tugberk Ugurlu, and I'm here today to talk about zero downtime deployments with you guys. So if I do my job well, at the end of this talk, deployments should be a bit less scary to you. Let me give you a bit info about myself. I work at a company called Redgate as a software developer. I live in a city called Cambridge in United Kingdom. I am also a Microsoft MVP on ASP.NET. And you can find me in several places, including Twitter, my blog, and then GitHub account. So, I mean, you may have this question in your head, what is this kind of stuff, right? But I'm hoping that it is not, you guys know what you are going to be getting at from this talk. Let me do a quick pulse check. How many of you guys have ever developed a web application? Quite a lot, nearly everyone. How many of you guys have you ever deployed a web application to production? Okay, nearly everyone. How many of you guys can do that without a downtime? Okay, that is awesome. Cool. Probably the hands will be higher after the talk, I guess. So let me give you a simple example. So let's assume that we have a HTTP API, and then this is running on a server, and then we have a few clients. One of them is like an Android client. The other one is another Android client. Someone else actually downloaded. The other one is a web client. So what we want to do here is like we have the version 1, right? But we want to release version 1.1 of the API because we made some changes and all that stuff. So in typical scenario, if we don't do our job well, what's going to happen is that we are going to take down version 1. During that time, the clients will not be able to reach to anything because we have taken it down. And then we will replace it with version 1.1. So today we are going to see how we can actually do the deployment without actually breaking the clients in the middle of that operation. But you may ask yourself, should I care actually? I mean, it's a so small amount maybe for you. Maybe you don't have that many, clients or that many users on your application that maybe it is like an overhead for yourself. Maybe you can live with this technical debt for a while. But I mean, it really depends on your situation. Again, this is the answer here is to every scientific question is that it depends. So here we are seeing something here which I'm sure that many of you guys are familiar with. It is saying that website is down, it's not reachable, we don't know the reason, but yeah, it's a cute message. Sometimes they are trying to make it more cute, but it doesn't really, makes a much difference because we want to use the service, we can't because it's not there. It can get a bit more scary. I have seen this on my way to train station while I'm trying to see the, train times. That was a bit scary. On my mobile application, I was seeing like they are doing a database migration. I was like, why the hell do I care about your database migration? It was a bit more, scary for me to see this. So if you want to, not give this type of messages to your users, you may want to, care about this. Well, you can say, okay, I deploy like every year or so. I don't really care about. Well, the next thing that maybe it's going to be valuable for you is the continuous delivery. I mean, how many of you guys can say that you are actually practicing continuous delivery at work? Okay, not much. So the continuous delivery actually has a business, value in it. So you can deliver your features in a fast manner as soon as you develop it, and then the deployment is not a cyclic wait anymore for you. So it is very, very important, I think, and it has a it's a very valuable technique and then the practice that you should be applying, I think, because it has a business value. It also has a technical value as well because you are going to be shipping more, and then you can catch the bugs And then as soon as you catch them, you can say that, okay, because of this deployment, this bug happened. And I know why it happened, because the changes were so small. So it has another value in that. But if your deployments are breaking your applications, you might have a psychic weight in your head that, well, I'm not going to do a deployment because it's going to break the thing. Maybe we will wait like 1 more week to get other features in, and then we can deploy more. So if you have these concerns, this might be very interesting for you. So what I'm going to be talking about today is coming from a true story, actually. So I told you guys that I work at Redgate, but I also do some side projects as well. So one of them is this thing called the leak. So it is actually, there is nothing out there yet, but we have been playing with this, and then it's going to be like, giving a different perspective on the personal eating, and then it's going to be your assistance in terms of eating. But the interesting is for you is the architecture that we have. So we want to have an architecture that is going to survive the deployments, and then that's going to survive high load and a high capacity. So what we have is like we have a few worker processes, we have a few type of data storage systems. We are embracing polyglot persistency as well, and then we also have a few nodes of our HTTP APIs, and then we will have some clients that are connecting to those APIs. And then the idea is that those clients will never be broken. So it should survive in any type of deployment. It should survive whenever we add a new feature. Those clients shouldn't be broken. So we will actually see, how we can do those in this type of architecture. So my experience is coming from trying to do this, and then we played around with this, and some of them are we just actually applied, and then we are seeing the value of this. Some of them are still like in theory for us, because we haven't shipped the version 1, so we can't see the actual other things. So, but some of the demos that we have done was very useful. But visually, what we are trying to do is, I think this GIF is explaining it very well. So we are trying to do this. Not with the cat, with the web servers. But we have a scope here because it's a very wide range. I mean, I can talk about this topic like for a day or so, but we need to scope this to something. So we are going to scope it for HTTP services and then websites. You may say that, well, websites are HTTP services as well, but they have different characteristics that we are going to see about those as well. So I'm actually going to talk about those. So I'm not going to talk about how we will mention it a bit about the databases, but we are not going to go deep in there. Also, we are not going to mention about your internal messaging system, and then how you can version your messages so that every component of your application can talk to each other nicely when you actually ship a new version. But let's say the path and guidance first. I think this is very important. Without actually trying to do something, we need to actually understand what we are doing. I think this is coming from the first thing that we need to do is to, I think, write down the deployment strategy that we have. So you have your architecture, you have your application in your head, and maybe you have draw a nice diagram as well. But you need to write down the deployment strategy somehow so that you can see what you are going to do. There was a saying, I guess, somewhere, but I don't know, I'm gonna quite get it right, but you can't actually automate something that you can't do manually. So that is very true, I think. And then there's a value on writing this down, because one thing is that you are going to see your steps in manual, written down manner, and then you can share this with your peers as well. And then whenever they ask, how is our deployment is working, here is the documentation that you can go and look at it. And then they will see it, and then you can collaborate on that rather than trying to collaborate on a actual automated process. So this is very valuable, I think. And then after doing this, what I would do is I would write down this, write down a script. It doesn't matter which language or which scripting language that you use. I mean, just have a script here that is going to be, doing the deployment strategy that you have written down in an automated manner, so that you can just run the script over and over again and see the results there. So this is an example. For example, this is a bash script that we have. It's you are seeing the partial of it, but it can be in any language, I think. And then now you have your deployment strategy. and then you have your script ready. Now you can start looking into release management systems, because what you are going to end up doing is that you will see that, okay, yeah, I can run the script, but I really want to see, which versions I have on the production and which versions I have on the servers. And then you want to have some auditing as well on that. If you have if you want to know which team member actually deployed the changes and all that stuff, you want to do some auditing on that as well. And then you also have databases on your application, and then you want to maybe track down those as well. So you end up building a dashboard for yourself, or you are going to look at a release management tool which is going to be managing this for you. I can give a few examples here. One of them is Octopus Deploy that I quite love. And it's a great release management software. I encourage you to go and check it out. The other one is Docker Cloud, which I'm very keen on using, but I actually haven't used it in practice, but I actually use it for some demos and all that stuff. But it's a very nice looking, it gives you a nice looking dashboard, and it also manages all of your nodes on the cloud environments, and it can deploy your Docker containers on the machines that you specify to it. So this is another part of the thing. So now we have, if we want to recap, we have our deployment strategy written, and you script it out. You found a release management software, and then you started using it. You pretty much have everything in your hand, but possibly you haven't considered some of the interesting stuff. So maybe you are doing the deployment in a way that we have seen in the beginning of the talk, but what's actually going to happen is that the hardest part is going to start from this point on. These are the simplest things that we can do beforehand. So I think the true staging environment is the fundamental stone here that we need to care about. I said true staging environment because some people actually see the staging environment in a way that you actually clone your database as well, but it's not like that actually, because when you actually clone your database, you have a copy of the data, and then whenever happens during that staging, you can't actually merge the two databases into each other. So you may end up, losing data in that way, which is a very bad practice. So I think the true staging environment looks like this. So we have our green box at the top, and it is our production server, and it has an application in it. And then we also have our blue one. Blue one is a staging environment that we have put in place, and it is identical to the production environment. The only difference is that our router load balancer doesn't know about it. So we have a load balancer here, which is the yellow one. As you can see that. How many of you guys doesn't know a load balancer? Anyone? Okay. Not much. Okay, cool. I will assume everyone knows because it's hard to explain. So load balancer actually, directs the traffic to the correct server, and then you can use it to scale your application horizontally, and then it will know which server to direct the traffic, and then it can balance that. So in here, our load balancer is looking at the green box. It's the production one, but our staging one is not being seen from the public traffic. We can maybe hit it internally or with a known DNS name that no one else knows, but it can't be hit from the outside because now it's not seeing it. So why do we need to have this then? What's the value of staging? I mean, you can understand the value of QA environment, right? Because your QA team is looking at that and everything. What's the value of this? And we can see the value from the blue-green deployments. How many of you guys have heard of this blue-green deployment before? Okay, yeah, some of you guys. Okay, great. So there's a great article on this from Martin Fowler. As you can see the link. I guess everyone can see that, I guess, right? We don't have this problem here. Okay, cool. So it's a very nice concept. It's a very good, practice on the doing the deployments, and we will see a demo of that. And then we will visualize it here as well. So here you see that we have our production database, production server, which is looking at our databases, and then our load balancer is looking at that production server, which is nice. Now we need to deploy a new version of the application. So what we are going to do is we are going to stand up a new server, and then we are going to make that server look into the same database, and it's identical to the production server as well, but the application inside it is new now. Maybe has new features, maybe has some couple of changes in it. We don't know actually. But what we are going to do right now is that we are going to make the load balancer look at the staging environment. So at this point, traffic is still going into the old system, right? New system doesn't get any traffic. But we will tell our load balancer to direct the traffic into the new staging environment, which we just promoted to become a production environment now. So now the blue one is a production environment. Our green box is now gone because we don't need it anymore. So with this way, the only time that you are spending here is just doing the swapping between the production to staging, and then that's all. That's all you spend doing the deployment in the public manner. I mean, internally, you are doing you are setting up a new server and doing all those work, and then you are putting the application in it. But publicly, you are just spending the time trying to do the, it's also called like whip swap in Azure. You may heard of this. Like you can have a staging environment, and then you can have a production environment, and then in Azure portal, you can do a whip swap to change the virtual IP address to look at the other staging environment. But we have a problem here, actually. Is anyone able to spot what the problem is? Database. No, not the database.
What if there is a problem right now?
Sorry?
Some major bug fixing occurred.
Not that problem. I don't know what you mean by that, but maybe?
New version with some problem.
No. Maybe that's a problem, but that's not what I meant. Sorry. Okay, so the problem here that we have is that we directly killed the old one without actually taking the ongoing requests into consideration. So we actually killed the old server right away. But maybe we have an ongoing request that the server is processing at that time. So what we have done is potentially we cut the requests which were in flight, and then made them say, sorry, we have deployed a new version, go to that. But it was in the middle of the processing. So we should actually drain the request before actually killing the old one. So let's see a visualization of that. Same thing, we have our server, and then we have our new server as well. What we are going to do now is that we are going to direct the traffic. Oh, okay, I'm just visualizing the same thing. Or did I go back? No, okay, this is the same thing, sorry. Forget that, see this. So we have our green server, and we put our blue server there as well. But what we are doing is now we are not killing it directly, we are making the request drain, and then we will make sure that there is no requests, that the server, or our old server is processing now. Because we are not directing the new request to the server, it's only the old requests that we had before, and then those are just being processed, and then we will wait for that. Most of the load balancers has a way to give that information to you. You can just ask it, is there any request which is in flight to this server? So you can just ask that, and then whenever the answer is no, you can just basically kill that server. So that's basically doing the blue-green deployment in a nice fashion. But there are still a few things that we haven't covered actually. Maybe the gentleman in front was mentioning about that. But so the changes that we make in our software is different. So some of the changes are major changes, like breaking the existing clients, and then it requires those clients to be rewritten. But some of the changes are internally, like maybe you are doing some bug fix which the users are not going to notice. Maybe you are just doing some refactoring and all that stuff, but you want to make sure that your code is functioning as the same way, and then you deploy the changes again. And so for this, I think the semantic versioning is amazing tool, amazing technique that we can use. How many of you guys have heard about semantic versioning? Okay, not much. So the semantic versioning has a very, simple idea in it. So let's take this version. So this is like 2.4.6, right? So in here we have 3 segments. So first one is the sorry, I have done it in a wrong way, I think. Sorry, guys. Just think that this is the last one. Just a second. I will fix this on stage. I think I still have time. Am I going? Are you taking my photo while I'm, fixing the slides? Yes. That's not cool, man. It's not cool. Not cool. Not cool at all. Can we cut this part from the video as well? It's a bit ugly now, but I think we will get the idea. Cool. Now the animation won't work, which is a problem, I think. This is PowerPoint, my friend, not Keynote. So let's see it here. Let's see it here. Okay. So I'm just giving it up now. Here, what we have is we have the first one, right? First segment. First segment is the major one. So major changes. So whenever we do a major change, first segment of the version is bumped. So what that means is that we are introducing incompatible changes. So these are the changes that's going to break our client. So what could those be? For example, in terms of the HTTP API, you are maybe removing a field from the from your JSON payload, and then your client is not going to be able to deserialize that. So it's a problem for the client. So those are major versions. There's also the minor version part of this, which you are adding a functionality, but you are adding that functionality in a backwards compatible manner. So your new users can use that functionality if they want to, but your old clients can stick without using it, and then they are not going to notice anything. And there are also patch changes, and then which requires you to bump the last segment of the version, and then those are the changes that are not user-facing changes. So that those could be bug fixes and the security fixes and all that stuff. So this is the heart of the semantic versioning, and it applies to libraries as well. But we are going to see how we can apply this to actual our application here. Cool. Cool. Okay. So in our application, what we can do is we can say that, okay, I'm going to be supporting 2 major versions at the same time, not more than that. So what that means is that whenever you deploy a new version, which is a major version, you don't take down the old one. You just keep that one, and then you just say that, okay, I have version 1 and version 2 at the same time, and then you can hit them separately. But whenever you deploy version 3, you kill the version 1 because now you have 3 on at the same time, and then you can kill the oldest one now. But this requires you to put a policy in place. Like, for example, I only support the old version for 6 months or 3 months, whatever works for you. And whenever I release a new version, I'm going to kill the oldest one. So you can, in your SLA or some kind of policy, you can define this. I think Twitter has this, or some other companies doing the versioning has this concern and that concept. But I think it's a very valuable concern, and then we can see it in place now. So let's do the minor and patch release, and then see how we can do that. It's a pretty straightforward comparing to the other one, but we will see that now. So what we have here is that we have our router, on the left-hand side. And then we have our 3 servers, 3 nodes of our same application, sitting on 3 servers now. And our load balancer is balancing the load to those servers. And what we are going to do is we are going to release the new version of our software, which is minor or patch. It's not major. And then we stand up the servers, we put the applications there, and then what we are going to do is we are going to do the same thing that we have done before. We are going to make the load balancer look at the new things, drain the requests, and then kill the old ones. That's all we are going to do. So now they are looking at those, and then now we can kill the old one. Drain the requests on the old things. When the requests are drained, and we can just kill them now because we don't need them. So this is basically how we can do the minor and patch changes, and then how we can do the deployment on those. And then what we have done here is that we have just basically taken down the old thing, and then there is a new thing now. And we assume that all of our clients, existing clients out there, mobile applications, web applications, can talk to this, talk to the new version of the software without actually noticing the changes. And we can document the changes, and then the new clients can adopt those changes and then use those features if you want them to. So I will actually give a demo now on this, and I will actually simulate this on in my machine through Docker. So the demo is actually sitting on my GitHub repository here. So here I have a GitHub repository, and you can see the link there, but I will blog about this after the talk, so you can get it from there as well. And this is basically the whole, demo that I'm going to be doing now. And there's a GIF as well. In case the demo fails, I can show you the GIF. And then it's also explaining what it is, and then how you can run the application on your box as well, and then see that, simulate a zero downtime deployment as well. So for this, I have this Ubuntu box here. Should I bump the fonts, or can you guys see that? Is it okay? Let's zoom in a bit more. Cool. So what I have now here is that I have Docker Compose as well. So I'm using Docker and Docker Compose here to get the setup running easily. But what this will do is this will stand up 6 nodes of my application, and then it's going to stand up a load balancer, HA proxy. It's going to stand up 5 clients that's going to connect to those APIs. And then those clients will send requests to those APIs 10 times a second. So I have 5 clients, and those clients are going to send, hit the APIs hard. Not that hard, but yeah, it's going to be noticeable for us. So I'm just going to do Docker Compose up, which will get everything up and running for me. And then, but first, when I, run this, you will notice some logs being written. So those logs are going to be written from the clients, actually. So we have 5 clients here, and all of those clients are written in a way that they are going to log a message on the console whenever they see a new server. So they will send a request to the load balancer endpoint. Load balancer will direct to a server, and server will put a header on the response indicating what's their IDs. And then the client is going to log those IDs, and if the ID is unique only. So this will allow us to see that whenever we change the new application, change to a new application, it will log those as well. It is failing, which is worrying. It shouldn't actually fail. Was it failing? No, it was not failing, I guess. Oh well. Not a good start. Luckily, I have a GIF. So I will do Docker Compose up here, and it will stand up all of the things for me, and as I explained, and then it will log the things And as you can see, APIs are up and running now. So the clients have logged, details here, as you can see. And then they are logging the ID of the server that they are getting the response from. And the load balancer is right now looking at only 3 servers, which are the version 1. But we have version 1.1 as well. So you can see that from the HA proxy, you can get these information. And the 2 means here that those are up and running now. And the 0 means those are idle. So we have actually 6 nodes. What we are going to do now is that I'm going to basically replace those nodes now. So I have done that, and then now you notice that there is no failure written on the screen, because what I have done is I have done the actual same thing that I have simulated up on the screen. So it has done this in a way that it enabled the new servers and it taken down the old ones connections. But requests are still being drained during that time. So any in-flight request is not being actually killed. So this is actually a very simple simulation of doing a zero downtime deployment. But you can apply this same practice to a cloud environment, against a cloud environment, or to a different load balancer. For example, AWS has its own thing, Elastic load balancer, I think. Azure has the same thing, has a different thing. So you can apply all of those. Cool. So there is one thing that I haven't mentioned to you is that, for example, in here, I used HA proxy. HA proxy has a config file. And then what I have done in demo was I haven't actually replaced the config file. What I have done is I have just, made the changes in memory. And whenever the HA proxy process is terminated and you need to get it up and running again, the config is going to be written from, read from the old config. So in HA proxy, it is a bit, interesting to do the config reload, but engineering team from Yelp has done amazing research on this, and that they have actually identified what is the downtime during that config changes. Maybe you are okay with that. Excuse me. Maybe you are okay with that downtime, but maybe not. But there is also a solution for this as well if you want to solve this problem as well. So for example, what we can do is we can actually adopt a new architecture in our server environment. What we can do is we can have one public load balancer and then 2 internal load balancers. So those 2 internal load balancers are not being seen from the outside. Only the clients are looking at the public load balancer. And then what our public load balancer knows about is the internal load balancers, and then it can direct requests to those 2 things. And then those are the 2 servers that it needs to know about. And then we are probably not going to touch those. What we are going to do here is we are going to do the same deployment strategy that we have done before, but in a different manner. So we will have our new servers put in place, and then we will make our second internal load balancer look at those. So second internal load balancer is now capable of balancing the load to those. And then we can now do the swapping from the public load balancer, and it will drain the request as well, and then it will cut the connection from the old instances. And now we can kill them because we don't need them anymore. And then you can do the reverse now, and then deploy the changes on the LB1, and then direct the load balancer to LB1 as well. So this is a way that you can handle this, and that this will not require you to have the configuration changes as well, because you have only 2 servers which you are looking at, and then you can just maintain them one by one. So for example, in this case, you can just maintain the LB1, take it down, do whatever you want with it. And this is a bit more healthy process, I would say. But we still have a problem. The problem that we have here is that our load balancer is not fault tolerant. We only have one load balancer, and if that load balancer goes down, or we need to do a maintenance on that, we have a downtime. So what we need to do here is that we need to basically have like 2 nodes of the load balancer that we can just take down one of them, do the maintenance, bring it up, take down the other, do the maintenance. Luckily, in HA Proxy, you can do this as well. But in cloud load balancers like AWS, ELB, and then the Azure's one, I think they are handling it for you, so you don't need to worry about that. You just need to use their load balancer. But in HA Proxy, you can just have 2 load balancers sitting in different servers, and you can just connect them together through a IP address. And then this will give you a fault-tolerant load balancer as well. So what's going to happen is that your healthy load balancer will get the request and then write it direct to the servers that it knows. And then if you do a maintenance on that, the second one will get the thing. So this is a bit more healthy. There's a nice article here that you can see. The link is here. So slides are going to be available after the talk, so you can get the link from there and then read up on that. It's a good read, actually. For the major releases, we have a different story because those are major releases. So we can't just replace the old version with the new version. So what we need to do is we need to employ a different strategy. There are different API versioning strategies that you can apply, but I think the most healthiest, the healthiest one here is doing the versioning through the URL. Basically with the domain name, having a subdomain. So for example, what I have here is a v0.example.com, and then it's looking at, there's a load balancer, and it's looking at 3 servers. Now I want to deploy a version 2 of that. So what I'm going to be doing is I'm going to stand up 3 servers and then deploy version 2 in them. And then I will stand up a new load balancer now, and I will stick a DNS name to that, which is v1.example.com. And you can now hit v1.example.com and it will talk to the version 1 of the thing. Not version 0 is still different, right? So what we have right now here is that old clients can still talk to v0, but you can document the new API and then version 1 of it, and then new clients can start using that. But you are not affecting, they are not affecting each other. So, and then here you can have a healthy period of trying to move to the new version, like 3 months or 6 months, so your new old clients can move to the new version of the API. Let's touch a little bit on the databases, which we haven't talked about, because that's one of our important part of our applications. So for example, this is a hard topic, and this is very dear to my heart because at work we are writing software to do those database changes. I can talk about this like hours, but I'm just going to briefly mention that. So simple rule is that do fast forward changes on your databases, not do them in a breaking manner. So for example, here we have v1, and the application is on the left hand side looking at the tables and the rows. And then in V2, we started not looking at the color column. So you can say that, well, we can drop the color column, right? But no, you can't do that because version 1 is still looking at the same database. So you are going to leave it there. When you have version 3, you can take down version 1 and you can do the cleanup on the database now. But you shouldn't do that in a way that it will break your existing applications. This is a very important part, I think, but it's not touching the whole thing because it has its own talk in a way. So the other thing is that do not overwrite client-side assets when you are actually writing web applications. So here, for example, we have the version 1, and we have some client-side assets like script and a CSS file. Now we have version 1.1, and then we will basically overwrite those with the new ones. But the you still have the old HTML file in place maybe, and then that file is going to read it, potentially read it from the old, from the new JavaScript and the CSS file, which potentially it doesn't know about, and it might fail. So you shouldn't actually do that. What you should do is you should apply the versioning strategy there as well. So you should version your URLs, put them in place like that, so that whenever you load a HTML file, it will know which one to load and do that thing. The other thing is, which is the mostly ignored thing, is to be aware of the context. In your web applications, you have cookies, you have sessions, you have authentication tokens. Those are being serialized to the clients, and then you are deserializing them and reading them on your applications. If you change the way that you serialize and deserialize them, you are not going to be able to read the old ones. So you should be aware of this, and then you should, take this into the consideration as well. That whenever you do change your way of, reading and writing the cookies and then the session cookies, you should basically be aware of the situation that you are getting into. The other thing that we haven't mentioned is the sticky sessions. So you may have, needs that you are going to make a client connect to the same server all the time for a period of time, maybe for the period of session time. You don't want it to change to the other server. So you can have sticky sessions. You can employ those, like saying that if you deploy a new version, I don't care about it. I'm just going to be keep looking at the old one because your needs are in that way. So there's a nice article on that you can go and check it out. These are some helpful links that you can go and check it out, which will be helpful to you, I guess. But other than that, this is pretty much it. Hope this was helpful. Thank you very much for listening to me. Hope it was helpful. Questions? Do you guys have any questions now? Yeah.
Can you tell us more about these database changes? Because this is, I think, most vulnerable place
Yeah.
for doing this. Because sometimes it's not so easy to make changes in the manner that aren't breaking anything in the previous version.
So database changes are, it depends on which type of database you are using, what type of stuff that you are doing. Everything is, there are so many variables. But there are some, practices that I mentioned, like you should always do your changes in a fast-forward manner. I have never seen a situation that you can't do those. So you should be aware of this. You should be aware of that, whenever I change my database, all of the applications out there can, read to that data. So you may say that, okay, yeah, I have stored procedures. When I change them, it's affecting those kind of stuff. But then your stored procedures are also your business logic now. So you need to version them separately. So we had an application before where we got into a situation where we started writing our stored procedures in a way that SP stored procedure V1, stored procedure V2, V3, which was a hell that we got into. But it was basically proving that we should have used the database as a container, not a business logic container. Yeah. So, it depends what your situation is, but maybe we can chat more afterwards. But I guess, the general practice is that do your changes in a fast-forward manner and then do the cleanups after all of your application is not looking at the data that you are actually expecting. The other thing is that some people actually want to do rollbacks on the databases. Rollbacks are scary and dangerous, which you shouldn't ever do that. We have a tool at our company called SQL Release, and then we got a lot of requests on trying to give us a command line which will roll back the database manually, but we haven't been doing this because the rollbacks are potentially going to lose you data, and then we can't actually guarantee that you are not going to lose data. So it's hard situation to get into. One more? Another question?
Yes, I have a question.
Yeah.
Could you explain one more how having two internal load balancers lowers the time, the downtime?
Sure. So, okay, sure. So the question was that how having internal load balancers are reducing the downtime. So in that case, what we have done was, I used HA proxy there. So HA proxy doesn't have a way to reload your config with a zero downtime. So you always get a downtime while you are trying to reload the config, because it's like requiring you to restart the process, basically, HA proxy process. So what we have done there was we have said that, okay, look, we are going to do that reloading behind the scenes, having two internal load balancers. So now whenever we need to deploy a new change, we just put them on a new server, make our internal load balancer look at that, and then we can write the config in that way because no one is actually touching that load balancer. And now we can direct our public load balancer to the internal one. So it's the only case that's helpful is the reloading the config case. But if you are using using a cloud load balancer like ELB, you shouldn't basically worry about that. You should just use one, and then it will handle that. And then those load balancers have APIs that you can hit them and then say that, okay, register this server with this load balancer, deregister this, and then they are doing it in a way that they drain the requests and all that stuff. So you get the benefit of a cloud infrastructure, which is managed by the cloud provider. So it's only the config as a short answer. We are done? Or can we take more questions?
Maybe one last one.
One last one. Any other? You are losing your... Okay, yeah. No? Okay. Cool. Thank you, guys.